Well, I'm on the last few questions here of the review for chapter 5, 6, and 7. I finished answering them one time, but I didn't have my mic on, so I'm starting over. Hey, how do you like that? Well, this time maybe it'll be a lot sweeter than it was last time, who knows? The first problem is a normal probability calculation. It's about chocolate chips in an 18-ounce bag of chocolate chip cookies. Okay. These numbers can't be right, but maybe they are. So on average, there's 1252 chips. Standard deviation is 129 chips in the whole bag, and it's normally distributed. That's important. Otherwise, we can't use z-scores or bell curves to do anything. And we got a few questions to answer. One is, what's the probability a randomly selected bag contains between 1,000 and 1,400? So that's a between two value normal probability question. We're going to compute z for both. So we're going to compute z for 1,000. So it's x minus mu over sigma. Mu was 1252. I'll write it down over here. X is 1,000. Mu is 1252. And sigma is given at 129. So z is x minus mu over sigma, like that. So we'll go over here and put 129 down here, and then we'll have another z for 1,400. So 1,400 minus 1252 over 129. That's a 5. Here we go. And we'll go ahead and compute those. I guess I'll leave that maybe here. So parentheses 1,000 minus 1252 divided by 129 minus 1.95 minus 1.95. And here, 1,400 minus 1252 divided by 129 is 1.15. I'm rounding. So we only get to use those two places in the tables. And we want between those two values. So we'll get the two probabilities here and subtract. So from the tables, minus 1.95 0.256. So if you're almost 2 standard deviations below the mean, the area left on the left is only about 2.5%. 2.56, 0.256. 0.256. And then 1.15. You're 1 standard deviation above the mean. 1.15. 1.15. 8749. So below there is 87.49. So that's the proportion of the area or the probability being less than that, 8749. 0.8749. And then the answer for being between, you have to subtract those two areas, 8749.0256. 0.8749 minus 0.0256. 0493. Sorry, can't be right. 8493. 8493, okay. So then what about the probability of fewer than 1050? Well, the tables give fewer than or less than probability. So we'll just compute z for 1050. And we'll go straight to the table. It'll give us the answer. So here we go, 1050 minus 1252 divided by 129, negative 157. And we go to the tables there, minus 1.57, 157, here we are, 157, 0582. Tables give 0.0582. And we want the what's the probability fewer than 1050? Well, the mean is 1252. The standard deviation is not very big. Fewer than 1050, not very likely. 5% chance. C says proportion of bags contain more than 1250. That's the same as the probability a given bag would have more than 1225. Same kind of calculation. 1225 minus the mean is 1252 over the standard deviation, 129. That's pretty close to the mean. So more than is going to be pretty close to a half. This is a little bit under the mean, so it's a little more than a half. We're going to get an answer here for a z that's a little bit negative. So it's parentheses 1225 minus 1252 divided by 129. So minus 0.21. And then we go to the tables minus 0.21. What's here? 21. That's 4168. So 4168 out of the tables. We want that more than. The tables give less than. And so the answer is 1 minus 0.4168. Okay, so that'll be 0.9932. No, that'll be 0.5832. Okay, better check that because I'm getting tired now. 1 minus 0.4168. 5832. Yeah, okay, fine. And then D, what's the percentile rank? Well, the percentile rank is just the proportion below, which is just exactly what comes out of the table. So if you're at the 95th percentile, then 95% of the values are less than that value. So since the normal tables give the less than proportion or the less than probability, it also gives the percentile rank. So it computes Z for, it's pretty big, 1425. That's quite a ways above the mean. So we'll put that in here. Z is 1425 minus 1252 over 129. Maybe that's 1.5 standard deviations. I don't know. Here we go. Put it here. There we go. 1425 minus 1252 divided by 129. 1.34. And then we'll look that up in the tables, and that'll be our final answer. That's for sure. 1.34. Yes, 1.34 is here. 1.34. Really? Did I get that? 1.34. It looks like the 91st percentile. Let's see, 1.34. 9099. Okay. The tables give 0.9099. And so we say the 91st, rounding it up, percentile. Okay, so that closes off this particular question. I think I can zoom out a tiny bit, can I? No, I can only zoom in, okay. So that's good enough. 91st percentile. Oh, let's just circle these. Okay, so there we go, and there we go. So there we go. That's the answer to the next. I've got 2 more to go after this. Let's just do them. All right. I made it fit. I'm excited by that. Okay. On we go. The next 2 are binomial approximation. So we're using the normal distribution to approximate the binomial. First, it's just given to you. Let's say, compute P of X using the binomial formula, then determine whether the normal distribution can be used to estimate this probability. If so, approximate P of X using the normal distribution and compare the result with the exact probability. The situation is N is 70, P is 76, and X is 0.76, and X is 57. So the binomial probability formula looks like the probability that you get a value is you take the combination formula, you take P to the X, and you take 1 minus P to the N minus X. We've got N. N is 70. P is 0.76. And X is 57. So we want 70C57.76 to the 57. 1 minus 0.76 is 0.24. And then I take 70 minus 57. That's going to be 13. That's the probability X is 57. 70C57. Okay, so now we're going to make that happen. Clear, on, okay, clear it again. Okay, so we start by typing 70. Then we go to math. Let me put this up here where you can see it. Then we go to math. We zoom over to prob. Go to NCR. There it is. And then we had 70 already in place. We're going to put 57 there. Oops. And then we're going to push over to get out of there. Then we're going to multiply. As I always type times, so I'm making sure I'm not way down there. And P is 0.76. We raise it to the 57. 57 is what X is, okay. And then we come over and we multiply that by 0.24 to the 13th. And come over, okay. Oh, double check, 13 plus 57 is in fact 70. So 70 minus 13, 70 minus 57 is 13. And 1 minus 0.76 is 0.24. I think we're all right. Off we go. 0.0669, okay. And change. So that's the exact answer. It says, find, can the normal distribution be used to approximate this probability? That's, for the normal approximation, you have to have NP times 1 minus P at least 10. So we'll try that out. N was 70, P was 0.76, and 1 minus P is 0.24. That's 12.76. Okay. I'll go 12.768. That's what it is. 12.768. It's big enough. And then we're going to go ahead and do the normal approximation. So for the normal approximation to the binomial, for this approximation, we use mu is NP. So that's the binomial mean. Sigma is the square root of NP 1 minus P. All right. I'm taking a look at my numbers again. 70 is N. P is 0.76. And 1 minus P is 0.24. Okay. Just doesn't look right, but I hope it is. Okay, so here N times P is 70 times 0.76. That's 53.2. And now this sigma is the square root of 12.768. 12.768. Raise it to the 1/2 power. 3.57. And now we have to be a little bit careful. We want the probability X is 57. The story there is like this. So here is, say, a histogram. Here's 57. We've got these bars like this. That'd be 58. Down here is 56, and so on. We've got some kind of normal distribution flying on top of there. We want the area of this bar here on top of 57. And so this side here is 56.5, and this side here is 57.5. So we're going to use those two numbers in a Z formula, and then we're going to subtract the areas left, and that'll give the area between. So we compute Z for each of those. For 56.5, it looks like that. And then for 57.5, we get this. Okay, so I'm using the mean here, 53.2, and I'm using the standard deviation, 3.57, we got from the binomial distribution. That makes a bell curve which matches up with the binomial shape. And then we want to find the area of this bar, width 1 over 57. So we go left a half and right a half. The left half is 56.5, right half 50. Okay, that looks good. And then we'll compute these z's. There we go. 56.5 minus 53.2 divided by 3.57. 0.92. And then I've got 57.5 minus 53.2, 3.57. 1.20. And then we're going to look these two up in the tables. I'm checking, they seem to be pretty far apart, but maybe it's okay. We'll know in a minute. So then we go to the tables. For 0.92, we're here, 0.8212. And for 1.20, 1.208463. Then we're going to subtract, and then we'll reach our moment of truth here. 0.8463 minus 0.8212, like that. So something appears to be messed up here. Let's see if I can find out what it is. It worked out for me last time. But where is it? I've lost my sheet. Hang on. So it looks good. I must have looked something up wrong. Let's see. Maybe my 1.2. 8849. 1.20. 8849. That's bad. How did I get this 8463? Bad things can happen. Oh, I did 1 point. I did it, and I switched it, huh? It happens. 1.20. 8849. Okay. 0.8849. Oh, it scared me for a minute. I knew something was up. 0.8849 minus 0.8212. 0637. Okay. 0637. And so we're comparing that 0637 to the 669. Pretty close. There's the approximate answer. Here's the actual answer. So the normal distribution did a pretty good job, even just computing the probability of being on top of one value. And we solved that problem. So I almost had to panic and start over, but I'm not going to give up that easy. Okay, there we go. Now we're on the last problem. Here it comes. Did I do everything? Yes, okay. That was a close call. Almost had to stop the recording and start over with a brand new screen. And I just want to get this done. And this is the last problem. And if there was a test question, I'd go, you know what? I don't care about these points anymore. I'm just done. But oh, whatever. We're going to do it. We are going to do it. It's another binomial approximation question. In this one, we've got in studies for medication, 5% of patients gained weight as a side effect. Suppose 420 patients are randomly selected. Use the normal approximation of the binomial to approximate the probability that exactly 21, no more than 21, at least 30 patients gain weight as a side effect. So first we have to figure out what n is. So n is the number of experiments, which in this case is the number of patients. P is the probability of success. Success is considered to be gaining weight. 5% is 0.05 chance. Okay. And then we're going to check that the normal approximation can be used. NP times 1 minus P is 420 times 0.05 times 0.95. 19.95. At least 10, we ask ourselves. Check. So that means we can use a normal approximation. So normal approximation will works. Okay. And then we're going to do exactly 21. We're going to use, well, 21 plus or minus a half from 21. So 20.5, 21.5 in a Z formula. And then we subtract the areas. So I know how to do it. For B less than or equal to 21, we're going to use 21.5. We'll draw a picture of that in a second. So we're thinking this, I'll put it here. So we're less than or equal to, so here's 21 here. The bar over 21 extends all the way up to 21.5. We've got a normal curve on top of here, but we want this area coming left to include the bar over 21. So we're going to start at 21.5. That's that one. On the other hand, if I just want the one just above 21, that's what this says. Sorry. That's what this says. Just above, okay, so we're just above 21. The one on this side is 20.5. So just above 21 goes from 20.5 to 21.5. For left of 21, I need to include it. We're including 21 because there's a less than or equal to sign there. So I need this bar and everything left. I'm going to start at 21.5 and shade left and get the table area. And then we're done. And for C, it says bigger than or equal to 30. Well, now 30 is playing the same kind of role as 21 was. 30 is here. I want greater than or equal to 30. So I take the bar over 30 and I'm going to shade to the right like that. So this side is going to be 29.5, a little bit less than 30. So we're going to use 29.5. And we'll get the table area. And then since we're going the wrong direction, the table is this side. We're going to go that way and then subtract from 1. Okay. So let's just go do it. Well, in order to get going, I need to know mu and sigma. Oh, I better have space. I do. Okay, so mu is NP. Sigma is the square root. NP1 minus P. That's the binomial mean and standard deviation formulas. N was 420, and P is 0.05. So 420 times 0.05 is 21. So that's 21. Sigma is the square root of NP1 minus P, so it's the square root of the thing we computed. So the square root, 19.95, go 4.47. Now that number sounds weird. I think I did this before though. Let's see, when I lost my mic. 20. I think I got the wrong number on my, well, I hope this one's right. Let's check it. Let's double check it here. Hang on. So N is 420 times 0.05 times 0.95. That can't possibly be wrong. That's NP 1 minus P. And then take the square root. 4.47. Okay, what did I think it was back here? I guess I just blindly thought that it was 4.67. I just misread it. Okay. Really? I think I just somehow forgot about this 4 and said 4.67, but I think we did it right. Okay. And then we're going to use those two numbers in Z. So here we go. Z is 20, 20.5 minus 21 over 4.47, and z is 21.5 minus 21 over minus 21, 4.47. All right, here they come. 20.5 minus 21, 4.47, okay. Negative 0.11. This will give us the same answer, but it'll be positive. So positive 0.11, like that. And then I'm going to go to the tables and look those up. 0.11. Heavens. We just had an avalanche, but I'm not going to worry about it. We're in the tables. We're looking at 0.11 and minus 0.11. Minus 0.11 is right here, 4562. For minus 0.11. And for plus 0.11, we're up here, right there, 5438. And now we subtract. My calculator survived the fall. 0.5438 minus 0.4562. 0.876. That's the probability of getting 21 patients out of the 420 reporting weight gain as a side effect. If the chance of having that weight gain as a side effect is only 5%, right around 9% of the time, you'll see exactly 21 of the patients that had the side effect. And now we're going to go less than or equal to 21. So what's the chance 21 or fewer patients had the side effect? So now we compute Z for 21.5. We got it here. And then the table area is the answer because it says fewer than. 5438. So now that's the answer already. So we already did some of the work. That's nice. And finally, how about being greater than or equal to 30? What's the chance 30 or more patients? The mean is only 21. What's the chance 30 or more? Well, here's the standard deviations, around 5. So 30 or more is just about 2 standard deviations above the mean. So not many would be, there wouldn't be many times when at least 30 patients had that weight gain as a side effect. It should be a small probability. So we go ahead and compute Z for that. 29.5 minus 21 over 4.47. All right, here it comes. 29.5 minus 21 divided by 4.47. 1.90. Now we want the chance that at least that number, so what's in the tables is not the right answer. We have to subtract that probability from 1. Find the area, subtract from 1. So 1.90. Yeah, I got 1.90. You can see it right there, 1.90, okay. 1.90 sits right here, 9713. So I'm going to go 1 minus 0.9713. I'll double check thy number. That's nice. 9713. 1 minus 97. Okay, we're just about done. I'm so happy. 1 minus 0.9713. So right around 3%, 0.0287. 0.0287. So nearly 3% of the time. So not very often. And there we have it. We've completed the last problem on the review. I'll just circle the answer so I know what I did. There it is. That's the answer to C. And now I'll just take this recording over to YouTube and hook it up with the rest of the recordings for the review solutions, and I'll have a complete set. And I'll see you later.